Hi everyone, and welcome to the AWS Nordics Ask Me Anything office hours. My name is Gunnar Grosch, and I am a developer advocate here at AWS. And welcome to this 1 hour of knowledge sharing from AWS experts. So this week, I am joined by Alexander Dragunov to talk about .NET on AWS. Welcome to the show, Alexander.
Thank you. So I guess it's time to introduce myself. My name is Alexander Dragunov, and I work as solutions architect at AWS. And my specialization is Microsoft or Windows workloads on AWS. And before joining AWS like 1.5 years ago, I worked for nearly 20 years as developer and architect. And most of my life, I worked with .NET since its very beginning. So that's why I'm very excited about this topic, about .NET. And I will share my knowledge about how to use .NET on AWS, why it's good, and what can you do so you're not scared anymore.
All right, that's great. Thanks very much for being here, Alexander. So this is an Ask Me Anything type show. So if you, the viewers, have any questions, just post them in the chat and we'll do our best to answer, be it on topic, .NET, or anything else regarding AWS. We'll do our best to try to answer that. So Alexander, to kick things off then, why is .NET important?
So I think the important thing here is that by estimates, around maybe 70% of on-premise applications they run on Windows Server, and most of these applications were developed in .NET. So we can say that .NET is a primary development language in many organizations, and especially Nordics, as far as we know. And so that's why, like, covering the needs of these developers, it's very important for us. And the .NET developers were much like any other developers. So they expect a rich integration with a development environment. And now I think we're talking about Visual Studio, Visual Studio Code. So they want fully featured SDK to the target platform. So they want, easy to use examples to start with, integrations with favorite libraries, etc. And that's why we think it's important to cover all the needs of this .NET developer society.
And do we do that at AWS? Do we cover
Yes,
the needs of .NET developers?
Definitely we do it, and we have quite long history of supporting .NET and Microsoft workloads in AWS. And I think I have a couple of slides, and the rest will be live demos. So I will show these 2 slides just to show our pace of innovation with regards to .NET. So I think many of you seen it because we use this slide quite often, but there are a few things which I want to emphasize related to .NET. So first, in 2008, so it's not 12 years, like 13 years ago, we released our first version of SDK. It was first version of AWS SDK, and the first version of AWS SDK was .NET SDK back in 2008. And the later Python come, like Node.js SDK comes, but I want to emphasize the first one was .NET SDK. And then we have a lot of support over the years of .NET. So .NET, for example, is a first-class citizen in Lambda. So you can create Lambda functions using .NET Core, and it's supported runtime. So we have support for PowerShell. We have AWS Toolkit for Visual Studio Code. For recently, we released the AWS Toolkit for JetBrains Rider. We have tools to support you in your migration journey, like Porting Assistant for .NET, and the story continues. And I will talk about this overview as well. So because we are going to use most of these tools during our demos. So when we talk about integration with development environment, so we have toolkit for Visual Studio Code, and for JetBrains Rider. So .NET developers, they will continue to use let's say Visual Studio, and right from inside Visual Studio, they can browse their resources in AWS account. They can deploy their Lambda functions or web applications. And when they want to interact with the platform, they will use SDK, and again, they can target both .NET Framework and .NET Core. Also, we have AWS Cloud Development Kit, where you can provision your infrastructure using the code. And again, C# and F# are supported in Cdk, and I will show it in the demos. Then we have tools for PowerShell. So everything that you can do with SDK, everything that you can do with AWS console, you can do it using PowerShell commandlets. So if you want to interact with your infrastructure using PowerShell, you can do it. And we have .NET CLI extensions, AWS CLI. So yeah, we have all the needs of .NET developers covered. And we know that many organizations, they use Azure DevOps. So we have integration with Azure DevOps. So we have the AWS tools for Azure DevOps. So that you can deploy to AWS right inside from your CI/CD pipeline built in Azure DevOps. And as I mentioned, we have tools to help you to modernize and your .NET Framework applications, so containerize them. So we have covered all the needs of .NET developers, as we think.
Yeah, I think those slides show pretty well that we do cover the needs of .NET developers. So I know you have a bunch of demos lined up for us, Alexander, to show a bit about .NET development. Before we jump into that, there is a question in the chat that I want to answer. It is not directly related to .NET, but I'm a C# developer, but currently also learning React. I want to expand my reach to DevOps. Which of the AWS certificates do I start with?
If you are, it depends. Like if you are brand new to AWS or you have already experience with AWS. So we have associate level certifications at AWS. So we have Solution Architect Associate, we have SysOps Associate, and we have Developer Associate. And with regards to DevOps, I think like Developer Associate certification is the closest one. So if you want to learn about our CI/CD pipeline, like how you work with code commit, how you work with code deploy, how you work with code pipeline, I think if you put a goal for yourself to learn about it on AWS, and if you do this AWS certified developer associate, then you will be in a good shape, I think.
Yeah, I think that's a great answer. So start up with the developer associate certificate and then aim for the DevOps Pro certificate in the long run, perhaps.
Yeah, I agree.
All right. So, Alexander, I recognize this. This is Visual Studio.
Yes. So again, as I'm .NET developer, so I love .NET and I love Visual Studio. So it's a great development environment. So I will do most of the demos from inside Visual Studio, but I will also show Visual Studio Code and I will show JetBrains Rider as well. So, okay, this is Visual Studio, and what we have here, we don't have any project. So I will start quickly by creating a new project. And I have Adblus Toolkit installed. So if you just search for Adblus Toolkit, you can download it and install it for Visual Studio. And this is Adblus Explorer, where I can see all the resources which I have in my account. So I can see my EC2 instances, or I can easily work with Amazon Simple Storage Service. So I don't need to go to console. So I can right click, create new bucket, or I can go to the bucket, see the files which are inside there. I can upload files, delete files. So no need to do anything from AWS console. You can do it right from inside Visual Studio. So, but let's create a new project. And with AWS Toolkit, there are also project templates which comes. So if I search for AWS, you can see that I can create CloudFormation project. I can create a Lambda function in Node.js. I can create Lambda function in C# and F#, and we have serverless applications, which I will show later. But let's start simply with Lambda function. So we're creating Lambda project, and it will be in C#. And it will be AWS Lambda live, because it's live demo. And then in order for developers to start, easy, we have blueprints. So you don't need to create something from scratch. You can select a blueprint, and then it will scaffold the code for you. So it will be much easier to start with. So you can, create a function which uses the recognition service to detect image, to label, to automatically label images, for example, or there is like simple DynamDB function, or you can connect to Kinesis, Firehose, etc. But we will start as simple as possible, so it will be empty function, and now you will see how complicated it is. So the project is created, and there is a function. And the function, each Lambda function should have an entry point. So this is the entry point for this Lambda function handler. So it takes a string as input. Then it also passes the Lambda context, which we're not going to use. And what it does, it returns uppercase string. So I don't know if it's possible to create more complicated function, but we will start with this one. Yeah. So this is a function, and there is also JSON files which tells about how this function is going to be deployed. So it says that we're going to use default profile. So I have Adblus profile on this computer. We're going to use Ireland region. It will use runtime for .NET Core 3.1. It will use 256 megabytes of memory. This is function timeout, and this is the important thing where we specify the entry point. So it's assembly name, namespace, class name, and function. So this is the entry point. Yeah. And what we can do just right-click deploy. So it's not something that you will do in production, definitely, but for development purposes, for testing purposes, it's very convenient for developers just to do this right-click and deploy to see if this function is working, how it's behaving. So, okay, let's do it. So we have two different package types. There is like zip one when we have managed runtime, or we have image one which uses Lambda container images, which we announced on last reInvent. And with container image, you can use any runtime, which resides inside the container. But because we're using managed runtime, we are going to use .NET Core 3.1. It will be, it's live. It will be our function name. Next. When we need to specify the role. So when the function is executed, at least it should have access to CloudWatch logs to put the information about how it's behaving. So I can just create a new role based on Lambda basic execution role. And then I'm leaving the defaults, like 256 megabytes of memory, default timeout. I don't need VPC. I don't need dead letter queue because it's the most complicated function ever. So let's click upload. So it will take a few seconds to create new IAM role and propagate it. But once it's done, the solution will be compiled, packed as a zip, and uploaded. So, and you see the function is already active. So what we can do, we can invoke this function directly from inside Visual Studio. So if I type bunch of small letters. It should be capitalized. Yeah. And we can see in the output invocation results. So it took 358 milliseconds and it used 65 megabytes of memory. But as you know, it was a cold start of a function. So if we run the function again, you see that now it took 1 millisecond to execute, and the build duration is 2 milliseconds. Because again, as you probably know, starting last December, now we build Lambda functions by millisecond intervals. Before it was by 100 milliseconds. So you see, .NET Core function and execution time is a bit more than 1 millisecond.
Yeah, that's impressive.
Yeah, and now, now we can see this function from our AWS Explorer. So here it is. So we can see resources deployed into our account, and here's our function. And again, we can view this function and we can execute it again right from inside Visual Studio. So easy.
Yeah, that was easy. So there's a question in the chat in regards to constraints regarding Lambda and .NET. Are there any differences in the feature set or anything like that when it comes to running .NET on Lambda versus other runtimes?
I don't think so, because it's a runtime managed by AWS. So, and if you need to access any kind of resources from inside the Lambda function, you can use SDK. And as with all other functions, you need to provide a role to access these resources. And there are same, from developer perspective, there are same considerations when you develop a function that you should reduce, like initialization time, or like you should do initialization outside of a function handler itself, so it can be reused by the further invocations. And then, if you use dependency injection, for example, you need to use lazy references again, like to reduce the startup time. But these are the same things you will do in your Java function or in your Python function. So exactly.
Yeah.
Same developer approach, I would say. Okay, so
so that was the first demo then. We've seen a .NET Lambda function being created in Visual Studio Code.
Yeah, and I can show quickly same function. So the Adblus toolkit for Visual Studio Code. So if I start Visual Studio Code, and you can install toolkit for Visual Studio Code as well. And then there is Adblus Explorer. So I hope I will see my function here as well. Yeah, and what I can do, I can invoke this function on AWS. So again, type in some string, invoke, and you see that the function was invoked. So same access to AWS account, both from inside Visual Studio and from inside Visual Studio Code. And if I do it from JetBrains Rider, you will see the same Explorer. And again, you can test your functions, access your environment, browse your CloudWatch logs, access S3, etc. But I want to mention that Visual Studio, the AWS toolkit for Visual Studio is the oldest one, so it has the most functionality. But the toolkits for Visual Studio Code and JetBrains Rider, we're constantly adding new features based on the feedback from customers, what they want to see first there.
Right. So what next then, Alexander? Now that we've seen how to create a Lambda function with .NET, and it was easy, I have to say.
Yeah. Okay. So recently, Microsoft released .NET 5, and many customers, they want to try .NET 5 in their applications, or they even want to run their production workloads using .NET 5. So we quite often hear from customers, okay, like what services do support .NET 5 on AWS? So like how can I start working with .NET 5 on AWS? And the issue here is that .NET 5 is not long-term support version of .NET. So .NET Core 2.1, .NET Core 3.1, they were long-term support versions, so they were supported for 3 years. And .NET 5, it's a current version of .NET. So this means that it will be, so .NET 6 will be released this November, everyone hopes. So this means that .NET 5 will be supported 3 months after .NET 6 released. And .NET 6 will be next long-term support version. So .NET 5 is current version. So the question is what we can do with it. And so there are different services which supports .NET 5. So one is Elastic Beanstalk. So we have managed runtime for Elastic Beanstalk where you can run your applications written in .NET 5, but we even support .NET 5 in Lambda. So if I create a new project, and again, I will choose AWS Lambda project, and it will be Lambda 3. And here you see the toolkit directly offers you 2 options how you can run your .NET 5 applications. So one is to use custom runtime. So this means that your function will be compiled like together with .NET runtime, so it will be one large executable. Or you can use .NET 5 container image, which is provided by AWS Lambda team. So we have .NET 5 runtime as container image, so we can use it. So let's do it. So
would you say that it's preferred to use the container image now that that's released compared to custom runtime?
Yes, because it's with custom runtime, you have same limitations as AWS Lambda. So it's size of function itself, for example. So it's limited to 250 megabytes as far as I remember. With container images, you can have images up to 10 gigabytes. So you can add more stuff into your Lambda function. And also you can customize your container images. So this is the Docker file which was generated by the toolkit. So we are using this .NET 5 image from our public container registry. And then we just copy the output of the .NET, our compiled .NET project into this image. But no one stops you from customizing it. For example, if you need specific libraries on Linux, then you can add them here. And one example is, as far as I remember, if you want to use system drawing on Linux, then you need to install some additional packages in order to be able to use it. And using container images, you can do it by customizing this Docker file. But let's see this function. And also, when we talk about .NET 5, we're not only talking about runtime itself, we're also talking about latest version of C#. So if you want to use latest and greatest features of C#, then you want to use .NET 5. And this is again as simple as possible function, but which is using the latest record type of C#9. So we're creating this record and we're returning a record which contains both lowercase and uppercase. So this function is a bit more complicated than the previous one. So, and again, what we can do, you can right-click deploy. So publish to Lambda. And here you see that the runtime is not applicable because it will be packaged as an image. So and the function name will be 5 live. So what Adblus Toolkit will do, it will create the Docker image, it will upload it to the container registry, and then it will instantiate it will run the Lambda function using the container image which was uploaded to the repository which you provide here. And again, we need to provide a role, and I think I will use the same, or let's create new one.
Right. So now you're uploading the .NET or the.
So first it will create the role, then it will build Docker image, then it will upload the Docker image, and then it will create Lambda function. So you see this Docker.
Oh yeah.
Yeah. Now it pushes the image to the repository. So it will take a few seconds.
All right.
So because it's based on the container image, so it will take maybe a few more seconds to create a function. But let's wait.
And this would be the same if you weren't using .NET 5, right? So it is because you're using a container image.
Yeah, exactly. Okay, so now the function is ready. So if I have input, if I run it, yeah, so it returned this record with lower and upper. And again, the duration was a bit less than 1 second. But if we invoke it again, it will not be cold start anymore. So it took 2 milliseconds to run this function from inside a container.
And having a bit longer of a cold start for a container image would be considered normal, I'd say.
Yeah, because just because you need to move more bytes into Lambda runtime from container registry.
So we have a question here that is related to cold starts. Then does it cache since the second time was faster? And can you explain cold starts?
Yeah, so this is not related to containers. This is related to how Lambda functions work in general. So when you run your function for the first time ever, then Adblus Lambda needs to create like execution environment for you. It needs to download the source code for the function, and then the runtime is ready for function to be invoked. When you invoke function for the second time, so you don't need to do these pre-warm steps anymore, because like the function is already, like the runtime is already ready. So
that's right. And if you don't invoke the function again for a certain amount of time, well, then you'll have a new cold start when it has to spin it up once again. And also, if it needs to scale. So, for instance, if you all of a sudden are getting a lot more invocation requests, well, then you might receive a cold start on certain invocations, because the Lambda service needs to scale in the background so that you're able to have that concurrency of Lambda invocations.
Yeah, but it's nothing specific to .NET runtime, so this is how Lambda function behaves.
Exactly. So no matter which runtime you use, you're going to face cold starts for the first invocation.
Yeah.
Right. So that was .NET 5 then. But what about legacy .NET Framework applications?
Yeah. So for Lambda functions, because the execution environment is based on Linux, and .NET Framework is bound to Windows, so you cannot use .NET Framework for Lambda functions, for example. But we have So if you want to run your .NET Framework applications, we have .NET Framework on Windows as supported platform on Elastic Beanstalk. So if you want managed environment to run your functions where you care only about your code, and when we care about underlying infrastructure, we care about like blue-green deployments, then you can use .NET Framework on Windows on Elastic Beanstalk. That's one option. So the second option is to use Windows-based containers. So both Elastic Container Service and Elastic Container Service for Kubernetes, they support Windows-based containers. So you can containerize your Windows applications and run them as containers, and improve like elasticity and all kind of things. And also we have tools to help you. So we have last summer we released a tool called Porting Assistant for .NET, which helps you to migrate your .NET Framework applications to .NET Core or to .NET 5. So this tool will not do the magic for you. So it will not do automatic conversion because still there is a lot of manual work needed, but it will help you in assessing the complexity of this transformation, like what is needed, what libraries are supported, where you need to find replacement. So it's a great tool to give a try. And the second one, which also released last summer, called Up2Container, which helps you to easily containerize your existing web applications. So if you have .NET Framework application running on iOS, then Up2Container can automatically containerize it, resolve all dependencies, create Windows-based container image, upload it to container registry, and even create like CI/CD pipeline to deploy this container to either Elastic Container Service or Elastic Kubernetes Service. So again, these tools are worth trying.
I'm trying to quickly post the links to those tools in the chat as well. So while you're talking, Alexander, there we go.
Okay, so I have another demo to show. So I showed how easy it is to start right from inside Visual Studio. Now I will show a bit more complicated demo on how you use our Adblus SDKs.
Just a question before we go there, Alexander, about the container size. Can you check how big that container image was?
Yes, so I guess we can try to do it right from here. So repository. So this is our repository.
Right, so it creates a repository for you for that image.
138 megabytes. So this was the container image for this .NET 5 test application which we created.
Yeah, all right, thank you.
But when you work with Up2Container, then you will create Windows-based containers, and the size will be gigabytes, not megabytes.
Yeah.
Because they will be based on Windows Server Core base image. Okay, so a bit more complicated example, and I will not create it from scratch. I have it ready. And projects.
While you find that, a second question on the same topic. The size depends more on the base image.
Yeah, so I think with 138 megabytes, it comes from the .NET 5 runtime on Linux, and then on top of it, there is your application, which is, I know, few megabytes.
Yeah, in this example, function wasn't all that complicated, so it can't take much of that space.
Yeah, but still, with container images on Lambda, the image size could be up to 10 gigabytes. And because it's Linux-based image, you have a lot of space for your application.
We have space to grow that function then.
Yeah.
All right. I'm going to stop interrupting you, Alexander. So back to the more advanced demo then.
Yeah, so more advanced demo, still it's like only one file, program CS, but what this demo does, it uses Adblus Recognition Sdk to detect faces on an image. And as I said, everything that you can do in AWS console, you can do it using SDK. And this is one of the examples. So I just referenced Adblus Recognition NuGet package. And what this example is doing. So first we are reading the file from a disk. So I just provide an image, some JPEG, and we are reading it. Then we are creating detect faces request, and this class comes from Recognition SDK, and we're specifying the byte memory stream as a source. Then we instantiate recognition client, and we need to provide the endpoint, the regional endpoint. So this is common for all SDK calls that you need to specify what is the regional endpoint. And when we call method detect faces async using the client and providing the request. And we got a response. And what we just enumerate the response, and then one of the results in this response is face details and the bounding boxes. So what we do, we just draw rectangle based on the information which we receive from SDK, and we save the output file. So if I compile it, and I have two examples. So this is one example, and this is second example. Maybe a bit more complicated because you see the face behind the other face. And so this is this recognition client, and I'm just calling and passing the source image. And for first one, it says 6 faces highlighted, and it generated this output file. So let's see it. This is generated right now. And you see it found 6 faces using Recognition SDK. And we can run it for the second one. And it detected all 4 faces. So this is how easy it is to consume AWS SDK from your .NET application.
Yeah, that was a lot easier than I thought, actually. Perhaps should have started with this, but .NET is not something that I've worked on before at all. So
maybe after this session you will start. That's
yeah, you never know.
That's my goal.
Yeah. Cool. So when in this case you ran this just locally,
yeah,
this solution. So this is then something that you could use more or less on any service that you talked about earlier that supports .NET then.
Yes, sure. So like this piece of code can be easily inside Lambda function, for example. So you can have Lambda function, which is triggered by event from S3, for example. When new image is uploaded to S3, Lambda function is triggered, and it does this face recognition. So it will be exactly the same code. So you will just reference Recognition SDK from inside your Lambda function. The only important thing is that you need to give Lambda rights to talk to recognition service. So you need to assign the role which has this policy to talk to S3 and to talk to recognition. Otherwise, it will be exactly the same code, but from inside Lambda function, for example.
Cool. So that was a bit more advanced example then. But when you showed the initial slide showing a bit of different developer tools and so on, you talked about CDK and .NET support for CDK.
Yes, so CDK, so again, I will mention it. So CDK is a way to provision your infrastructure using the code. So instead of writing YAML files or JSON files of thousands of lines of code, you can do it from inside Visual Studio. You can use C# classes. You can use if statements, for loops, so all kind of good constructs. You will have IntelliSense, you will have compile time checks, so all the good things about writing code. And C# is supported in CDK. So let's try it. So I will create new folder.
In the meantime, if you just joined us, we are at the last third of this hour, AWS Nordics office hours. I'm joined by Alexander Dragunov today. We're talking about .NET on AWS. I've been so intrigued on the topic that I've forgot to mention it several times that this is the Ask Me Anything edition. So if you have any questions, just put them in the chat and we'll try to answer them. We've seen several demos from Alexander using Lambda, using Visual Studio and Visual Studio Code, and now we're on to CDK.
Yeah, so I created just empty folder, and you see it's empty. And now we are going to create a CDK sample application. So how we do it, Cdk Init. Here we have two options, either up, it will be completely empty, or we can create a sample app which will have a queue and a topic. So I will create this sample app. And when we specify the language, so in this case, it's C#. The less known feature of CDK that it also supports F#. So if you're favorite of F#, you can type here language F# and it will scaffold the test application using F#. And I will use Visual Studio Code this time. So let's see what was generated for us. So it generated with CDK JSON file. So all the CDK CLI commands you have to run from inside CDK JSON. And then there are sources. So it generated normal Visual Studio solution. So we have program, and the program creates this CDK demo live stack. And inside the stack, so what I have a queue. So this is SQS queue, and I'm specifying visibility timeout. And then I create a SNS topic, and for topic I am adding subscription. So C# code, easy to read, easy to follow, with IntelliSense, so I can specify now dead letter queue, whatever. So, and it's only 5 lines of code. But if we do, let's see how we can deploy it. So first, if I run cdk diff, it will, what it does, it compares what I have in my Adblus account to what I'm going to deploy and shows the differences. So like you see that if I run cdk deploy, it's going to create a queue, it's going to create a queue policy, it's going to create a subscription, and it's going to create a topic. So, and if I run cdk deploy, it will do it for me. But I have another application which is, I guess, more interesting to show.
Yeah.
Let's see. So it will be static website. So yeah, so this is the stack. So what are we going to do? We are going to deploy static website using S3. So first, we are creating a new S3 bucket, and let's name it somehow. See, IntelliSense in action. The main problem with S3 buckets is to make the name unique. Okay, hopefully it's unique. So, okay, I'm creating an S3 bucket. I'm saying that I want public read access. The website index document will be index.html, and this will be the bucket name. Then I need to create a bucket deployment so that I specify the content of this bucket. So I create bucket deployment. I specify the destination bucket, the one which I just created, and I specify the sources. And the sources, it's what will be the content of this bucket. And these assets, they reside in this site contents folder. So it will be Cdk live, faking the demo. So, and then what we do, we output the URL of the bucket which just created so we can browse it. So let's see if it works. So again, first we will run Cdk diff to see, to confirm what we're going to deploy. So it compiles the project. Okay, so these are the resources which are going to be created. And again, you see like 5 lines of code, but we're going to create a S3 bucket. We're going to assign bucket policy. Then we are going to create a Lambda function. So this is the Lambda function which will upload the source code for us. Not source code, but the site content for us. And then we have a role, we have policy, and as an output, we output the bucket name. So looks good. Run Cdk deploy.
Now we'll see if any of the viewers managed to create a bucket with that name before your Cdk is done.
Yeah. So because we are modifying policies, it asks, okay, are you really want to do this IAM policy changes? Are you sure? Yes, I do. So you see like 9 steps. So it will maybe take a couple of minutes to deploy.
So in the meantime, we have a question while that is deploying. For a local .NET development environment, what local emulated services exist and works with .NET?
Good question.
Yeah. I suppose, for instance, if because I think you mentioned that AWS SAM is supported.
Yeah, I'm now thinking about SAM. So this will be the same services which SAM supports, but you need to work using like SAM CLI in order to have to access it. So it's not something you will get from inside Visual Studio, but SAM supports .NET. So
yeah, so you can use SAM local or invoke local to then invoke your .NET runtime Lambda functions.
Yeah.
Right. So in the meantime, I can try to find a link to that as well. posting that in the chat right now about local testing using AWS SAM.
Okay, so the bucket is deployed and you see the output. So this is the URL. So if I copy it and if I open browser, it's Cdk Live. So we have our static website hosted on AWS S3 and we did it using SDK and we wrote the code using C#. So how good is that?
That is really good. So if you just make a quick change to something now and do a diff and then deploy that.
Yeah, let's, what would we change? Let's make, I will have this error page. So I cannot just change the site content because the CDK stack will not understand that it needs to deploy the function. So I need to change something here as well. But I don't know if I just change the bucket name, for example.
Yeah.
So I added one more letter, and if we run CDK, if now we'll see what has changed. Yeah, so you see the difference. So the bucket name was 12111, and I added the. So what it's going to do? It's going to recreate the bucket. So it will drop the old one and create the new one with a new name. So it's a best practice to run CDK diff all the time you make the changes, so there are no surprises in what is going to be deployed.
Yeah, that could have been a surprise otherwise. All right, cool. So we are reaching the top of the hour, 8 minutes left. So if you have any .NET related questions, make sure to post them in the chat before we end this session while we have Alexander here.
And I think I have one more demo, which I'm really like. So as you know, AWS has ARM-based servers based on AWS Graviton 2 processors. So these are 64-core ARM server CPUs, and we have a lot of services which runs on Graviton 2. So I guess a couple of days ago, we announced that Amazon Aurora now runs on, now supports Graviton 2 processors, and you can run Redis cache in it and many Linux distributions. So, and .NET 5, it runs great on ARM. So there is a, so what I did, I created Ubuntu EC2 instance based on Graviton 2 processor, and I installed .NET 5 SDK Init. So now I just SSH'd into this instance, and if I run .NET info, so you see that I'm running .NET 5 on Linux on Ubuntu ARM 64 based machine. And let's quickly create, just to demonstrate that it's really up and running.
Yeah.
Create an ARM demo folder. And then I will just create a new .NET application. So standard .NET new web app. So it will be empty ASP.NET Core web application. And let's run it. .NET run, and then I want to expose the URL on port 5000. So it's .NET 5 application, which is built on ARM-based Linux instance. And now it's listening on port 5000. So if I If I grab a new, so, and on port 5000. So this is ARM demo. So I have ASP.NET web application written in .NET 5 running on AWS Graviton 2 processor. So
That's
how cool
pretty
is
cool.
that? Yeah.
Yeah, that is cool. So some of the benefits with the Graviton 2 processes are the price performance. So they offer a lot of performance for a lower price. So how performant is .NET on ARM?
Yeah, so our colleagues in United States, they made a test of .NET 5 on Graviton 2, and they so the results of the test are that it's up to 40% price performance increase when you run the same workload on Graviton 2 compared to running it on Intel-based instances. And I think we have a blog post around it. I can quickly try to find the link.
Yeah, that's super interesting. Since well, with the ARM revolution, if we call it, with Graviton 2, it is really interesting to see that you're able to run your .NET applications as well.
I don't know how I can post the link.
If you post it in the chat to me, I'll make sure.
Yes, I posted it for you, and then you can post it for everyone.
There we go.
And yeah, based on this article, you can play with Graviton 2 yourself. So I think these small instances, small T family of Graviton instances, they are free. So like they're under free tier, so you can simply play with them and check yourself that it works and how it works.
Yeah, super cool. All right, Alexander, we're approaching the end of this session. So a quick recap then, what we've looked at during this hour.
Yes, so we showed that .NET is a first-class citizen at AWS. So we supported starting 2008. .NET SDK was the first version of SDK which AWS released, and we continue the pace of innovation. We support it on Lambda, we support it on Elastic Beanstalk, we support it in containers, we supported it in Cdk, and yeah, you can even run it on Graviton 2 instances. So full spectrum of AWS compute services and support from everywhere.
Yeah, I am convinced. So I'll definitely give it a try after this. I like it. So perhaps we'll even have you back, Alexander. I think the audience has appreciated this. So give a thumbs up to Alexander, everyone, for being here today. And thanks, everyone, for watching. It's been a great stream and a lot of knowledge sharing from Alexander to everyone. So thanks a lot, Alexander. Thanks, everyone, for watching. Join us next week as well.
Thank you for inviting me.
Yeah, it was fun. And next week, I'm going to have Tim Gustafson on to talk about databases on AWS. So that's going to be an interesting one as well. All right. And with that, have a great day ahead, everyone. And thanks again for watching.
Thank you.